Okay, in this video we are going to solve a problem of mass spring application. So it's very important to translate what is in the description of the problem into the values of the differential equation. Okay, so let's start. A mass weighs 24 pounds. It stretches 4 inches a vertical spring. Okay, so let me write here weights 4 inches vertically. Initially, the mass is released from 3 inches above the equilibrium point. Find the position, the formula of the position. That is inciso A, inciso B. Find the amplitude, the period, and angle phase. Okay, now, so let's start with by the way, it doesn't say anything about the friction, so I will assume it's a free damping model. Okay, now, okay, so let's start. Okay, so a mass weighs 24 pounds and it stretches 4 inches a vertical spring. Okay, so this is the spring without any mass. Now, when it is attached, then it is stretched with here 24 pounds. Okay, so this distance is 4 inches. Okay, now we have to convert this into feet. Why we need to do that? Because the speed the velocity is actually in feet. Alright, so these 4 inches, if 12 inches is 1 feet, or foot, by the way. Okay, so this is 1/3 of feet. So this is not 4 inch, this is 1/3 of feet. Alright? Okay, now that it has 24 pounds, that becomes our equilibrium position. So this is the x equal to 0. Okay, now, what we need for the differential equation, if you remember, is going to be the mass x second derivative plus kx equal to 0, because it doesn't contain the friction force. So what we need is the mass and this proportionality k of the Hooke's law. Now, first the mass. Now, this 24 pounds is not the mass, is the weight, is a force. Okay, so the weight, it is actually the mass over the weight is the mass times gravity. So the mass is going to be the weight over the gravity. So the weight is 24 pounds and the gravity is going to be 32.2 feet per second square. So that is why we need to convert these inches into feet, because the gravity is in feet. Okay, now usually it's going to be 32.2, but let's round it to just 32. All right. So so how much is the mass? The mass is going to be, so the mass is going to be, let me see if we can reduce that. 3/4 only. So it's going to be 3/4 slugs. Now, this is in English units. So we are not in Mexico. We are not used to the English units. We are more used to the metric, which means meters, kilograms, newtons, and so on. But here is the measurement for the mass. So 3/4. So we got this number. All right. Okay, now let's continue. So that's the M, and by the way, from the K, the Hooke's law says that the force is proportional to the distance. Now, here is the information. 24 pounds was the weight, the force applied, and the distance was 1/3 of the feet. So the K is equal to this to the other side, and that is going to be 72. All right. And that is newtons per meter. Pounds. Pounds per feet. So that is the value of the K. So with this information here, with these 24 pounds stretches 4 inches, so that is the distance and the force applied. So from there you calculate the K. So we got the K. Okay, so the differential equation is going to be 3/4 x second derivative plus 72x equal to 0. Let's multiply these times 4 to avoid the fraction, so it's going to be 3 x second derivative plus 72 times 4 288 x equal to 0. Okay, next is actually the initial conditions. Okay, let's continue reading. Initially, the mass is released from a rest 3 inches above the equilibrium point. Okay, so somebody comes here and push the spring and the mass up 24 pounds. Here's the equilibrium point, so here is 3 inches, okay? Divide by 12. Is going to be 1/4. So this is going to be 3 inches is going to be 1/4 feet. Alright? Okay, so now the important thing here is the above. So here we have our initial condition. So it says that x of 0 is equal to 1/4. Okay? Now remember, up is negative, so this is minus 1/4 feet. Now another thing here important is from rest. So the initial speed is going to be 0. So with this we have our initial conditions to calculate the constants. Okay, now here this is the resulting differential equation. So the characteristic equation is going to be 3p squared plus 280 equal to 0. So p squared is equal to minus 288 over 3. Alright, so that is equal to minus 96. Alright, now just let me check. Yes, and then the p1 and 2 is going to be the square root of, here is actually plus and minus. Plus and minus the square root of 96. So that means 0 plus minus the square root of 96 is actually, let me check. Okay, 4 square root of 6i. Okay, so as expected, it is an imaginary root, so the solutions are like this. x of t, it is actually c1 cosine of 4 square root of 6t plus c2 sine of 4 square root of 6t, and that's it. However, well, this is just half of the problem, because we have found x of t, but we need to find what is the values of c1 and c2, and to do so, that is why we need these initial conditions. All right, to find c1 and the c2, we need two initial conditions because there are two constants. Okay, now the first one is in the position, but the second one is on the derivative. So what we need to do here is to calculate the derivative. So x prime of t is equal to derivative of this. Derivative of the cosine is the minus sign, minus 4 square root of 6c1 sine of 4 square root of 6t plus the derivative of the sine is the cosine, alright, but times this 4 square root of 6c2 cosine of 4 square root of 6t. Okay, now let's calculate the constants. Okay, the first one, this is just the calculation, so I'm going to, this is just the calculations of this. Okay, now let's do the x of 0. X of 0 is, here the time is equal to 0, that is the initial, because it says here initially. So initially means time equal to 0. So it's going to be C1 cosine of 0. I don't care about this number, it's cosine of 0, plus C2 sine of 0. And that is supposed to be equal to minus 1/4. Okay? So the sine of 0 is 0, and the cosine of 0 is actually 1. So from there we can calculate C1. C1 is clearly minus 1/4. Alright, now the other one, x prime of 0. So on the x prime of 0 is equal to minus 4 square root of 6 C1 sine of 0 plus 4 square root of 6 C2 cosine of 0. Okay? So, and that is supposed to be equal to 0. Now, I don't care about this. This is going to be 0, and the cosine of 0 is going to be 1. So what is left is here 4 square root of 6 C2 equal to 0. So C2 is equal to 0. Alright, now, because, so the solution is this. X of t is equal to C1 is equal to minus 1/4 cosine of 4 square root of 6t plus C2, but C2 is equal to 0. So that is all the things. Okay, so what happens here, engineers, is that you don't have to apply the formulas of the previous video because you have a single cosine. So the amplitude is already minus 1/4, where it's actually 1/4. Okay, positive because this minus is just starting below. All right. Now the phase is equal to 0. Okay, because we don't have to translate this, but the period is going to be, according to the formula, it was 2 pi over beta. Let me remember the formula. Yeah, okay. So that is the formula. So it's going to be 2 pi over the beta, 4 square root of 6. And this is the period to repeat for this to be like this. So what will happen is that somebody comes here 1/4 up and then release it, and then it's going to do something like this. Okay, so to make a full cycle is going to take this amount of seconds. Alright, and the amplitude is 1/4, which is actually the first, the distance that you gave at the beginning. So that is the 1/4. So that makes sense, right? Okay. So in this problem, we didn't have to use the formula of the amplitude, angle, phase, and the period. Well, here we use the period here, but to calculate the amplitude, we didn't have to. Okay. With this, we finish the unit. And please solve the homework. You have everything to solve the homework. And see you on the next unit.